Hopefully, I'm live. I'm not sure, but yeah, let's see. Let's see what's in the box. So, basically, my overall plan is let me just first explain the structure that I want to study, in which I want to study for like 3 to 4 months. So, honestly, I've lost a lot of opportunities, but I just never want to lose again, and I just want to win. So, this is the plan that I will follow. Uh, so first of all, I will start with multivariable calculus, in which I will uh, go through vector matrices and planes, 3D you can see, and uh, after that I will jump into probability and stats. So this is the core thing that I want to study because um, this is the thing that is required in quant. I'm preparing for quant, so yeah. Then I will go to linear algebra. Linear algebra is, you can also debate that I should study linear algebra before probability and stats, but it's fine. It won't cause me so much of trouble because I have a little bit grip over linear algebra, but nevertheless, I am dumb. I will just study from scratch. Um, so okay, yeah, you can debate, but I believe it won't cause me a lot of problem. After that, I will go with maths, maths with application in finance, because as I said, I am preparing for quant, and that course of MIT, maths with application in finance, it's good. It described a lot of sets, application, variations that often asked in or in quant. uh, as recently in Optiverse Future Focus, there was polarity modeling kind of things, which was in this course also, and also it got asked into Optiverse Future Focus. Okay, after that, so this is the core thing that I want to do as soon as possible and with a proper deep understanding. After that, I will do single variable calculus and multivariable calculus. So I will do multivariate calculus in two parts. First here, which is just basic things, and after that I will do the core thing that I want to. So okay, let's get to our course, which is this thing. So in multivariate calculus, we have first part as vectors and matrices. So it is divided into three parts: vectors, determinants, and planes; matrices and system of equations; then parametric equations for curves; then exam also. Yeah, I will do exam, I will do problem set, because I think uh, that's how I understand it properly. Because if we just watch lectures, YouTube lectures and all, I don't think I grasped the topic that well as compared to when I do problem sets, when I do quizzes, when I prepare for the exam thoroughly. Yeah, so I'm planning to finish at least part A and part B um within this week, or in 5 days, I would say, because uh, I think I can do this in 5 days. Let's see. I don't know, but I just hope. Okay. Also, I do want to show you, or show me, at this point of time, I would say, because no one is watching it uh, right now. I will do in two tracks. So one track is for proper maths, where I will do these kind of things that I explained, and I will do CS. Not only this, but also core CS like net, computer networks, OS, DBMS, COA kind of things that I also want to study. I will do it parallelly, but maybe at a slower pace, because for these things I have time. For these things, at least till finance with maths, I don't have much time, but I want to study it thoroughly. So, yeah, let's see how it goes. Also, if sometimes or someday I got bored, I don't want to uh, spend a lot of time in CS or maths, because it will happen someday. So in those days, I will just go through, prepare for the problem sets, and study the things that I want to study, like poker theory. I want to study poker theory. I want to learn poker. So I will just uh, study poker theory too. So poker theory is poker is fun, honestly, for me. I've seen a lot of games, but I never played, never uh, got to play poker. But I want to play. I want to uh, develop the thinking process for poker, strategic thinking. So yeah, if I get bored someday, I will uh, study poker theory or game theory, or kind of astronomy or cosmology kind of things. So whole all in one. That's the whole plan. Now now comes the main topic, main thing. So yeah, we do have to study now. So let's just jump into it. I just once want to see what's visible in my screen on and what's not. Okay, so I will start with vectors. Also, I don't know how do I show everything that I'm doing at this point of time, because um, well, I'm working on two screens right now, so I don't know what's visible, what's not. So these are the, so in this screen I will just write the notes or anything, or solve the question, whatever is due, or I want to do. Um, and in one screen I do want to study the theory or the problems that instructor will show. Also, probably I will link up everything that everything and every of my notes, each of my notes, after the stream, uh, in the description, or I will make a Notion folder, and yeah, we can do that. I've talked a lot, I think. Probably I haven't talked that much in my whole day, but I talked a lot in just 8 minutes and so I think we just have to start. Okay, so let's start with vectors. Also, the core reason why I started doing live. Okay, it's important to say, that's why I'm explaining before jumping into the videos, uh, because what happens in community games or during quant interviews, you have to think about the problem uh, at the same spot and explain it properly, what's going on into your mind. So basically, maybe this is the part where I lack. So I know how to solve the problem, but how do I explain it properly? That's the main question. So uh, I do try to, through this live stream, I do try to learn the things that I want to explain. How do I explain the things that's that is going on in my mind. So yeah, I guess we should start with this session one. Okay, first session. Don't we have lectures? Okay, we do have lectures, but I like reading PDFs, so I will read that too. Can I? I think I can't. Yeah, let's go through PDF once. After that, we will just go through a lecture. Okay. Okay, so these are just basic. So I just went through the 1.5 pages so far. You can go at a faster pace, of course. So yeah, vector do have magnitude and a direction. This is the core basic. Then the magnitude of vector A will be A under the mod. So actually, let's make a, okay, let's not go. I thought to make a note or explanation, but yeah, it's fine. Uh, I just remembered I'm studying for myself at this point of time. Okay. Okay, so there was one more interesting thing. This is the thing which is interesting, or okay, whatever. So if you want to find a displacement, so how do I explain? I will explain here. So let's make a new page. Let's call it rough explanations. And yeah, so um wait a minute. Okay, so let's say let's say here's a point, and if there's a vector, okay, I don't know why it's not working. Okay, I'm trying to do it in a pen tab, so I know I will just do it here. Yeah, it's working there, but not here. Okay, it's fine. So as described in the problem statement or explanation, so we can find displacement in simple terms mean shortest path. So this is okay, it's not a straight line, but I was uh, so consider this as a straight line, I would say. That would be generous. So let's say the shortest path. So this is the shortest path between point, let's call it A, let's call it B. So this vector is the shortest path, and also if you want to place the vector A and vector B, then that would be it. So this is, I guess, explained in this example too. And for the subtraction, this is actually opposite. We have to, so here notice one thing. Okay, I just figured out there was a error in my figure. So this is head and this is tails. We have to draw it again, or what? Okay, so um basically there shouldn't be a there shouldn't be tail to tail connection at this point of time, because if we do tail to tail connection, then we are tend to subtract the vectors, and if we uh, push it tail to head or head to tail, then it's fine. We are adding it. That's what I wanted to say. I made it a bit lengthy and confusing, but bear with me, I am a newbie too. Okay, so So thought of thought of as displacement a minus b is the displacement from the end of b to the end of a. Okay, this thing is to the end of a to the end of b. Yeah, it's understandable. We are matching tails here. That's the whole point now. Use subtractive vectors either by placing tail to tail or by adding the positive and negative side. Okay, so we are placing tail to tail in this direction. um let's I just got a thought process. um Maybe I'm wrong or I'm right, you guys have to decide. But what it actually want to say, if this is tail to tail, so what tail to tail means here, this is going in a positive route, this is going into a negative route. So they will, if they will uh, they will collide or whatever they do, they are in the opposite direction, so that they will get subtracted. And if they are in the same direction, we can add it. Okay, okay, it makes a total sense right now if we understand this thing in the in much easier sense. So tail to tail means they are going in the opposite direction, that's why we can subtract it. And this tail to head means they are going in the same direction, so we can add it. Okay, it makes sense now. Let's see what's next. So let's read this once. So this is a figure. O is the origin. uh, we constructed we constructed a, so its head in a direction upwards, which is in xy direction, a1 and a2. And okay, what's next? In this way, the coordinates of the head determine the vector a. Okay, when we draw a from the origin, we will refer to it as a origin vector using coordinate. Yeah, got it. Addition, subtraction, and scaling using coordinates is discussed below. So graphically it's like this. So the vectors I and j used in a figure uh, above have coordinates I equal to 1 comma o. So 1 comma 0 means I, yeah, so 1 unit from here in x axis, in yeah x axis, and 0 unit from y axis. Okay, and then vector j, so j is what, 0 comma 1. So j is a 0 unit, j moved 0 unit in x axis and 1 unit in y axis. Okay, makes sense. Notation and terminologies indicates the points in the plane. Okay, a1 a2 equal to uh, a vector I and j. This is equal to a vector drawn from the origin for vector a. Okay, P equal to OP in the vector. Okay, what's P? P equal to from O to P, but where is P? Is a vector. Is there any graphical explanation of P, or P is the hypothetical term here? P equal to is the vector from the origin to P. I can say I can see P here, so it's for below or what? Okay, we will see P. What's P? Fine. I have to zoom in a bit. Yeah, it's fine now. Yeah, now it's clear. So on the blackboard, vectors will usually have an arrow above the letter. In print, we often drop the arrow and just use the bold face to indicate a vector that is, yeah, yeah, it's basic terminology. A real number is scalar. You can use it to scale a vector. Okay. Oh, vector algebra using coordinates for vector uh, a1 I plus a2j and b1 I plus b2j. We have the following algebraic rules. The figures below connect these rules to a geometric viewpoint. Okay, Pythagorean theorem for addition. What we do? Okay, for addition, what we can do is we can uh, we can add the x-axis and y-axis together. For sorry, in separate terms, like um here. So can I go below? So let's say we have a1, a2, b1, b2. So let's say it's x and y, x and y. It's for a1 is for x-axis, b1 is for x-axis, and same with for I and j, let's say. So we can add a1 plus b1 like x-axis together, and a2 plus b2. That's the rule for addition, I believe. That's what I saw right now. um, yeah, yeah, that's it. And for subtraction we will do the same. Got it? Let's say it graphically. that will that will give us more weightage. Wait a minute, where's my OneNote? Yeah, so let's say on a plane, this is a plus b, which is the shortest path between vector a and vector b, and this is a2 plus b2, this section, and this section is a1 plus b1. Does it make sense? Let's have a look. Okay. um okay, it totally makes sense. So this is a1, this thing here from here to here. I hope my cursor is visible. If it's not, then it might be a problem. But yeah, yeah, it's visible. I just checked. So this is A1 and this is B1. If you press the, even if there is magnitude, then we can just add these numbers. So from here to here and from here to here, we can add this and we get the whole length. Okay, it's fine. And for subtraction, what we can do, so this is A1 minus B1, this is A1 minus B1, so this whole is A1, and if we minus B1 we'll get the area. Yeah, it's understandable. We can get this figure. Yeah, okay. How much is left? We are about to end the first session. I don't know why it took me a lot of time to just study the basics, but I want to go slow, and then we can speed up later on. So yeah, let's understand the next thing. So for 2 points P and Q, the vector PQ, will equal to uh, Q. Yeah, Q is bigger and P. Okay. Yeah, PQ is displacement from P to Q. Okay, got it. Vector in 3 dimension, so in which we have Z space 2 apart from X and Y. So geometrically, nothing changes for vector in 3 dimension. They are scaled and added exactly as above. So what is extra is we get another dimension which is Z, so we can play with it too. So algebraically, the origin vector A1, A2, A3 starts at origin and extends to the point. Okay, we have the spatial vectors I. So I do. So I is for X, J is for Y, and K is for Z dimension. So using them, we can make. Yeah, we can make this. It's okay. Then for A equals to this, B equals to this, we have, yeah, it's same as above, we just have an additional dimension. And in Pythagorean theorem, yeah, basically this is how we find magnitude. You can see this in the figure below, where R uh, A1 plus A2 square and magnitude of A equals to R square. So R square is basically this thing. This thing is R square. And then we can figure out this. Yeah, it's fine. So here R is basically this, and we are adding one more dimension, so it will be this. Okay, unit vectors. So a unit vector is any vector with unit length. When we want to indicate that a vector is a unit vector, we put hat above it. Okay, this is a sample. The spatial vectors I, j, k are unit vectors. Since vectors can be scaled, any vector can be rescaled to unit vector. Find a unit vector that is parallel to 3 and 4. So since 3 and 4, 3 comma 4 equals to 5. Oh, the vector this has unit length and is parallel to how it's equal to this. Okay, let's Let's do it for once. Okay, I think I do need to convert it into something, some good kind of paper style, so that I can even solve it. Okay, this is fine. Okay, so what was the question? Can I just minimize this thing? Yeah. Okay. Okay, let me first adjust it. After that, we can go in a flow. Okay. Okay, I believe it's fine. It's kind of small for me too, but okay, it's fine. So what we have to do is, so it's simple now. Let's say it's 3 comma 4 magnitude of this, so it will be 3 square plus 4 square, so 9 plus 16 25 under root 25 under root equals to 5. So yeah, that's how, so that's how 3 comma 4 magnitude comes out to be 5. But the vector, why we put 1 by 5, how it's inverse? Okay, I have to study again. Okay, unit vector is any vector with unit length when we want to indicate. Okay, since vector can be scaled, any vector can be rescaled to unit vector. Find unit vector is parallel to this. Okay, let's just ask AI why it happened. What do I write? Okay. Okay, bear with my English, only this AI can understand my English. Okay, so we solve the magnitude thing. Then after that, if a vector has length 5 and you scale it by 1 of 5, the new length is, oh, okay. So this is the interesting thing. We keep the direction, but we just shrink it to 1 so that it would be a unit vector. Okay, it was interesting. So if vector has length 5 and you scale it by 1 by 5, your length is 5 into. Okay, thanks perplexity. I think we are done with this session. Should I just, is there anything more to read for this session? I don't think so. So okay, the following images show the chalkboard content of the file. Okay, let's see what's this. Okay, the length of a equals to, I think we should watch, what I should watch, I would say, the lecture 2. Let's view the example once. Okay, find a plus b plus c vectors or displacements. A plus c is net displacement of the following. So it was in which shape? Okay, I'm not too sure how we can convert this shape into this geometrically, but the text makes sense, but shapes I do have to study more. Find a plus b plus c where a equals to this. Okay, here we just have to, we should just do it once. We have to just categorize the things we just did now. Here, what we did here, we have to do the same in this problem. So remember, a comma 2 is shorthand for I plus j axis. Okay, for I axis plus 2j. So another way to say is as, so here unit is 1, here unit is 2, where this 1 I came from. I have no clue where this 1 I came from. And okay, I have to solve the question first. There are two questions, I believe. Yeah, they are okay. There are two questions. In one, we just have to calculate. So this is on the easier side. And what's this? Okay, here we calculated everything, and it comes out to be 4 comma 1. So what's next? Remember 1 comma. Let's just solve it once. After that, we can hover over. I think I will just keep it full screen, and I will just hover into, I will just bring my uh, one note whenever I do want to solve, because it feels easier to me that way. Can I make my page longer or anything like that? I hope I can. So I don't know, I just hope I can do this. Okay, so we can also mentally solve this now. So uh, a is 1 comma 2, so 2 4, so it comes out to be 4 in x-axis, and in y-axis 2 2 minus 1, it's 1 4 comma 1. It's simple. Then what do I have to do with 1 comma 2? Remember, 1 comma 2 is shorthand for, yeah, it's fine. So on the way to say is as a plus b plus c equals to I comma j. Oh, okay. So what it's saying at this point of time, that um, let's say we are writing 1 comma 2, okay, the same example, and if we write it as I comma 2 j, then it's same, because if we write 1 or not, it's same. Here unit is 2, so we have to write 2 and j for the y-axis. Yeah, okay. I just complicated it. So here it got written as 4i plus j. Okay, okay, it was fine. So first session was okay-ish. It was simple. It should be simple. It must be simple, I would say, because it was the first session. Okay, I need to speed up now because I did things. I opened up my mind, I guess. I made silly mistakes which I shouldn't, but I made some. But now I feel I opened up my brain. So man, how many lectures or examples are there? Okay, let me just see the video first. It's of 11 minutes only. We can watch it.
Hi, welcome to recitation. In lecture, you started learning about vectors. Now, vectors are going to be really important throughout the whole of this course. And I wanted to give you one problem just to work with them in a slightly different context than what we're going to do in the future. So this is the context of Euclidean geometry. So some of you have probably seen this problem that we're going to solve, but you probably haven't seen it solved with vectors. So let's take a look at it. So what I'd like you to do is
Okay, let's just
show that the three medians of a triangle intersect at a point, and the point is 2/3 of the way from each vertex. So let me just remind you of some terminology. So in a triangle, a median is the segment that connects one vertex to the midpoint of the opposite side. So here this point M is exactly halfway between B and C. So every triangle has three medians, one from each vertex connected to the midpoint of the opposite side. And what I'm asking you to show is that these three medians all intersect in the same point, and also that this point divides the median into two pieces, and the big piece is twice as large as the small piece. So this is 2/3 of the median, and this is 1/3 of the median. So why don't you take a few minutes? And the big piece is twice as large as the small piece. So this is 2/3 of the median, and this is 1/3 of the median. So why don't you take a few minutes, work that out, try and do it using vectors as much as possible. Pause the video, come back, and we can work on it together.
I think I need to study more. We'll go there. I want to be prepared for that question. I will brainstorm on that question. So okay, let me finish all the examples then. Okay. So when we are finding vector lengths, we will take magnitude of it. Okay, it's fine. Man, the thing is, the answer is written just below the question, so we don't get time to brainstorm. But it's fine. We just have to take the we just have to work upon the Pythagoras part on that. So let's do one. So let's just say is 1 plus 2 plus 3. So square of all of this and under root. So 9 plus 13, 14 under root. Yeah, that was in the answer too, right? Yeah. So it's fine, I can do this. Okay, what was that? I didn't understand. The lecture is of good quality. Of course, it's from MIT, so it must be. So next is force is a vector. Yeah, proof is signature vectors. Okay, the picture shows two tugs pulling a barge. Okay, if one pulls with this Newton, 2000 Newton of force, what force should the other tug pull to keep the large going straight into right? Okay, so as mentioned in the answer to whatever tug it's whatever force it's pulling at 40 degree, so we have to uh, take the vertical components of the force to cancel it out. So this is sin 30. Okay, so if this is sin 30, then it will be sin 35. Okay, yeah, makes sense. Next one, proofs using vectors. It it sounds very theoretical, but let's see. Okay, it's the same thing na, that was discussion that he was discussion in the uh, video. Okay, first let's understand what's happening here. The median of a triangle is a vector from a vertex midpoint of the opposite side. Show the sum of the medians of a triangle is 0. Sum of the medians of the triangles is 0. The medians of side A and B um, is a vector from side A and B. So, so where is A and where is B? The median of the side A and B is a vector from C. A and B is a vector from C. Okay, yeah. Vector from vertex C to midpoint of AB. Label midpoint as P. As usual, we write P for the origin. P for the origin. So OP. Okay. The midpoint P equals to half of midpoint P is equal to half of A plus B. A plus B half. Okay. And CP. C and P will equal to half of B plus A CP minus C. B plus A minus C. Yeah, makes sense. Okay. Likewise, BQ, B and Q. So here it's same thing, but for B, like consider it's as same. Just replace it. Replace C to B, B to C, B to here, and P to Q, Q to P. If I'm right. Okay, so half of A and C is minus B. Yeah, and AR is half of B plus C. AR B plus C. Yeah, it's dividing it's in half minus A minus A. Yeah, the sum of the medians are, yeah, okay, yeah, makes sense. Okay, let me once check if I am live or not. Okay, it's been 1 hour, I guess. Yeah. So yeah, I just checked and yeah, I'm live. I'm live, but I don't know why the sound is glitching out or what. But here, let's see what's happening. So, so indirectly or directly, whatever I should say, I just crossed 1 hour, one studying hour of mine. That's what matters. I don't know how mid back the live stream is, because I just feel like the stream is a lot behind of the actual thing. But okay, let's just go on to it. So what's left in this session? I think I've completed the session 1 apart from the lecture. So we do have to come to this. So in session 1 we just have this lecture and PDF left. We have completed all of that, all of the above stuffs. So one thing which was uh, intriguing to me was proof using vectors. It was kind of complicated, not complicated, but it was kind of interesting. So yeah, let's get to this.
So hopefully you had some luck working on this problem. Let's get started on it. So to start, I actually want to rephrase the question a little bit, and I'll rephrase it to an equivalent question that's a little bit more clear about how we want to get started. So another way to say this problem is that it's asking us to show, so for each median, say this median AM here, where M is the midpoint of side BC, there exists a point on the median that divides it into a 2-to-1 ratio. So the point that's 2/3 from the vertex to the midpoint of the opposite side. So for example, there's a point, say let's call it P, say, at first. So there's a point P such that AP is twice PM. Okay? And similarly, there's some point maybe called Q that's 2/3 of the way from B to the midpoint of this side, and there's some point that's 2/3 of the way from C to the midpoint of this side. And so an equivalent formulation of the question is to show that these 3 points are really the same point, that they're all in the same place. So one way we can do that is that we can compare the position vectors of those 3 points. And if those 3 points all have the same position vector, then they're all in exactly the same position. So in order to do that, we need some origin. And it happens that for this problem, it doesn't matter where the origin is. And so I'm not going to draw an origin, but I'm going to call it O. So we're going to set up a vector coordinate system with origin O. And now I want to look at what the vector from O to P is in terms of the vectors for connecting O to A, B, and C. Right? Those are the vectors that determine the vertices of the triangle. And so I want to relate the location of P to the locations of A, B, and C. So the first thing to do is that, well, in order to talk about where P is, I know how P is related to A and M, and I know how M is related to B and C. So let's first figure out what the position vector of M is in terms of the position vectors of A, B, and C, and then we can use that to figure out the position vector of P. So M is the midpoint of the segment BC. So I think we saw this in lecture. What this means is that the position vector OM is exactly the average of the position vectors of B and C. It's 1/2 of the quantity OB plus OC. All right? So it's easy.
Okay, I think I just read the same thing in the proof section. Like yeah, it was just describing this. Let's see what we have. We have OM here. Wait, it's little bit thick, so to make it light. So what's happening here is let's say vector OM, it's half of OB plus OC. So that's the same thing that we read in the proofs using vectors in this PDF. So here is OM from O to M. Let's just see the figure once. Okay, so here is OM, this is O to B, and this is O to C. So OM equals to half of O to B plus O to C. Okay, what's next? It's OP. Where's P? This is P now. So O to P. What will happen at O to P? So it is half of to P O to C. Wait, in case of OM, yeah, O to half of O to C and O to A. That will happen. O to A. Okay, 2/3 of what? 2/3 of A to M. Okay, A to M. So A to M. So O to 2/3. Yeah, it makes sense in this way too. Okay, this is something interesting. Let's watch.
The average of the position vectors of B and C. It's 1/2 of the quantity OB plus OC. All right, so it's easy to express the position vector of the midpoint of a segment in terms of the position vectors of the endpoints. You just add the position vectors of the endpoints and divide by 2. So if you like, this is equivalent to the geometric fact that the diagonals of a parallelogram bisect each other. So that's the position vector of M. Now we have to figure out what the position vector of P is. So in order to do this, we can note that in order to get from the origin to point P, well, what we have to do is we have to go from the origin, wherever it is, to A, and then we have to go from A 2/3 of the way to M. All right? So the vector OP is equal to OA plus 2/3 of the vector AM, right? Because it goes 2/3 of the way from A to M in order to get from A to P. This is because we've chosen P to be the point that divides segment AM into a 2-to-1 ratio, so that AP is 2/3 of AM. Okay, so good. So now we need the vector AM. Well, we know what the position vector of A is. It's just OA. And we also know what the position vector of M is. It's OM. So that means that AM is just the difference of those two vectors. It's going to be O. We know what the position vector of A is. It's segment AM into, right? Because it goes 2/3 of the vector AM, right? Because it goes 2/3 of the way from A to M in order to get from A to P. This is because we've chosen P to be the point that divides segment AM into a 2-to-1 ratio, so that AP is 2/3 of AM. Okay, so good. So now we need the vector AM. Well, we know what the position vector of A is. It's just OA. And we also know what the position vector of M is. It's OM. So that means that AM is just the difference of those two vectors. It's going to be OM minus OA. Another way to say this is that if you add OA to both sides, you have that OA plus AM equals OM. In other words, to go from O to M, first you can go from O to A and then go from A to M. All right, and I've just subtracted OA onto the other side here. So we can write AM in terms of OM and OA. And we have an expression for OM here in terms of OB and OC. So that means we can get an expression for AM in terms of OA, OB, and OC. So let's do that. So that's just by substituting from here into here. So if I do that, I get that AM is equal to, so OM is 1/2 OB plus 1/2 OC. And now I just subtract OA. All right, so that's what AM is, putting these two equations together. I get that that's AM. And so now I need to figure out what OP is. So for OP, I just need to substitute in this new expression that I've got for AM. So I have OP is equal to, well, it's equal to OA plus 2/3 of what I've written just right above, 2/3 of AM. So that's 1/2 OB plus 1/2 OC minus OA. Okay, and so now you can multiply this 2/3 in, just distribute the scalar multiplication across the addition there, and then we can rearrange. We'll have two terms involving OA, and we can combine them. So we'll see we have a plus OA minus 2/3 OA. So that's going to be equal to 1/3 OA, and then we have, okay, so 2/3 times 1/2 OB, so that's plus 1/3 OB plus 1/3 OC. So this gives us a simple formula for the position vector of P, that vector OP, in terms of the position vectors of A, B, and C. So in particular, it's actually, because P is this special point, it's 1/3 of their sum, of the sum OA plus OB plus OC. Okay, so that's where P is. Now to finish the problem, I just have to show that this is the same location as the point that trisects the other medians. So how would I do that? Well, I could go back to my triangle and I could do exactly the same thing. So I could, maybe I'll give this point a name also, I'll call this midpoint N, say. So I could let Q be the point that lies 2/3 of the way from B to N. And then I could write down the position vector of N in terms of OA, OB, and OC, and then I could use that to write down the position vector of Q in terms of OA, OB, and OC, and I'll get some expression. And what will happen at the end, I hope, if I'm lucky, that expression will be equal to this expression that I found over here. Okay? So you can go through and do that, and if you do that, what you'll find is that in fact it works. So there's actually a sort of clever, shorter way of seeing that, which is that this formula is symmetric in A, B, and C. So that means if I just relabel the points A, B, and C, this expression for the position vector doesn't change. So rather than going through that process that I just described, you can also say, well, in order to look at say Q instead of P, what I need to do is I just need to switch B and A. I need to do exactly the same thing, but the roles of A and B are interchanged. Well, if the roles of A and B are interchanged, then the resulting formula, I just have to interchange the roles of A and B, but that won't change the value of this expression. So by symmetry, the point I get really is going to be the same. If you don't like that argument, I invite you to go through the computation, this computation again in the case of the other medians. In either case, what you'll find is that the points that trisect the three medians all have position vector 1/3 OA plus 1/3 OB plus 1/3 OC. But that means they're the same point. So what we've shown then is that the points that trisect the three medians, that divide them into 2-to-1 ratios from the vertex to the midpoint of the opposite side, that those 3 points all have the same position vector. So in fact, they're the same point. And that's what we wanted to show, right? We wanted to show that there's one point that trisects all 3 of those medians. So we've shown that the 3 points that trisect them are actually the same. So that's the same conclusion, phrased differently. So I think I'll end there.
Yeah, so I think I got the solution how we can solve this. At some point of time, like at 5-minute mark, I felt that it was a bit complicated, but the explanation later on was quite good, and I caught up to that. Also, I think this is a recitation video, so we haven't yet studied the main lecture video, and I don't know if lecture videos comes under the like Creative Commons part or not, but yeah, we have problems now. I It's tempting to click on solutions, but yeah, I'll first look onto the problems. So we have four problems. Uh, I just hope there isn't any coordinate geometry problem like this one because it was complicated, but yeah, it would be fine. So isn't it like the same thing that we were doing? Uh, like from one is going okay, one goes into positive direction and another goes into the negative direction. So let's say this is the case. So what should be the approach if we just take out the it's 45 now, 36 plus 9, yeah, 45. I don't think it's 35. It would be something like positive 3 or negative 3. I don't know what I'm doing. I have to see the first solution. No, I was very far from the answer. Okay, maybe I am solving this a little too early. Or am I not? Pi by we get to the solution pi by 6. The theta with the oh, I thought it would be this simple. I'm dumb. We have to use trigono here. Yeah, in upstream problems, we generally have to use trigono. So so it was mainly of a trigono problem, uh, applied trigono problem, I would say. Okay, fine. So here we have to do the same thing which we did in 1 by 5 or 5 wala case. So to get a unit vector, we scale the original vector by 1 over its length. Yeah, so 9 plus 4, 13, 13 under root. Yeah, use the vectors. Diagonals of the parallelogram bisect each other. Okay, I think I did this during my JE times, but I forgot. Okay, I'll just go through it because I don't think proving kind of things I need at this point of time. But yeah, this was interesting. Let's see from here. Use the proof using vectors method. The midpoints of the sides of the space of quadrilateral form a parallelogram. Okay, we'll just skim through the proving wala problems because I don't want to spend a lot of time in these proof kind of problems. It will uh, help me to understand the problem, but I can skim through it. I think so. and the problems which we can solve, we will solve. So let's see. Let's intersect at the mutual midpoints. Okay, so what was the fourth question? Okay, so this this one wasn't that complicated, but it was a good one. Prove using vector methods that the midpoints of the sides of the quadrilateral form a parallelogram. Four sides. Okay, it was a very intriguing question. So first we have to visualize that the midpoints of the quadrilateral will form the parallelogram. So here here's the midpoint of every uh, vector of the quadrilateral, and from here we have to visualize first the parallelogram, and after that, if the parallel sides of the parallelogram are equal, then we have to construct the equation from here. Okay, it was a really good one. Okay, what are the major contents left now? So vector, can we just go from here? There should be a resource index kind of thing. So yeah, this is the problem set which I will solve um, after doing everything without seeing solutions. Hopefully it don't have some proof kind of questions, because if there is some proof kind of question, I then okay, I will just see it and skim through it. But let's see, does it have some proof questions? Okay, dot product, cross product, angle. Bro, what is this question? Okay, I will just read it at the time of exam only. I'm just skimming through it, so it have the proof questions or not. So at MIT, underlying problems must be done and turned in for grading. The others are some such choices. Okay, so these are the underlined problems. So we have to definitely solve this. And is these aren't the underlying problems, so we can solve this for practice. So part 2 is kind of like this. Okay, problems are in, specifically supplementary, but we we must have to solve underlying problems, and we can also solve the non-underlying problems for more grading and more marks. Okay, I don't know what is this question, so it must be a interesting one. I have to build a thought process for it. So yeah, um, so what is this supplementary problems? Let's see once. Section 1 party supplementary problem. Okay, let's see what is this supplementary problems. So these are the more problems for which we can solve, right? Okay, it's cool, it's cool. We will solve. uh Definition, action is just a unit vector with this. Okay, we just have to find a magnitude and direction for this. For what values be a unit vector? So it will be for 5. Not sure. No, not sure, but I'm just guessing around. 1A2. Okay, 1A2. I'll just see 1A2 answer. I just guessed 5, so what's that? 1A2. It's not 5. Okay. Okay, but I after seeing the answer, I got the thought process that how we can solve it. But I shouldn't. I want for next and any of the questions. Okay, so let P and Q be 2 points. I have to revise Trigno too. Okay, Trigno is my revision list too. I haven't. I won't slash. I haven't taken any Trigno classes, so I have to. I have a book of Trigno that I will revise. Yeah, that's what I'm planning to do. Like I don't have to revise too much of Trigno. I just have to skim through the formulas and what. Yeah, formulas only. Formulas and a bit of concept. Like there isn't much concept in Trigno, but okay, there is just too much of formulas. So yeah, we can jump to dot products. So before sleeping tonight, I'm planning to do, I don't know, maybe section 5 determinants. Uh, Okay, can I reach 5, section 5 before sleeping? It's tough, it's gonna be tough. Okay, first just see the lecture. This is lecture, right?
So now we're going to learn a few more operations about vectors. And these operations will be useful to us when we start trying to do a bit of geometry. So of course you've all done some geometry, but we're going to see that geometry can be done using vectors. And actually in many ways it's the right language for that. And in particular when we learn about functions, we really will want to use vectors more than maybe the other kind of geometry that you've seen before. I mean, of course, it's just a language in a way. I mean, we're just reformulating things that you have seen, you already know since childhood, but you'll see that the notation somehow helps to make it maybe more straightforward. So what is dot product? Well, dot product is a way of multiplying two vectors to get a number, a scalar. And, well, let me start by giving you a definition in terms of components. So what we do, let's say that we have a vector A with components A1, A2, A3, a vector B with components B1, B2, B3. Well, we multiply the first component by the first component, the second by the second, the third by the third. If you have n components, you keep going, and you sum all of these together. Okay, and important, this is a scalar. Okay, you do not get a vector, you get a number. I know it sounds completely obvious from the definition here, but in the middle of action, when you're going to do complicated problems, it's sometimes easy to forget. So that's a definition. What is it good for? Why would we ever want to do that? That's kind of a strange operation. So probably to see what it's good for, I should first tell you what it does geometrically. Okay, so what does it do geometrically? Well, what you do when you multiply two vectors in this way, I claim the answer is equal to the length of A times the length of B times the cosine of the angle between them. So if I have my vector A, and if I have my vector B, and I have some angle between them, I multiply the length of A times the length of B times the cosine of that angle. So that looks like a very artificial operation. I mean, why would we want to do that complicated multiplication? Well, the basic answer is it tells us at the same time about lengths and about angles. And the extra bonus thing is that it's very easy to compute. If you have a component, see, that formula is actually pretty easy. So, okay, maybe I should first tell you, how do we get this from that? Because in math, one tries to justify everything to prove theorems. So if you want, that's a theorem. That's the first theorem in 1802. So how do we prove that theorem? How do we check that this is indeed correct using this definition? So, or in more common language, what does this geometric definition mean? Well, the first thing it means, before we multiply two vectors, let's start multiplying a vector with itself. That's probably easier. So if we multiply a vector A with itself using this dot product, so by the way, I should point out we put this dot here, that's why it's called a dot product. So what this tells us is we should get the same thing as multiplying the length of A with itself, so squared, times the cosine of the angle, but now the cosine of an angle of 0, cosine of 0 you all know is 1. Okay? So that's going to be length A squared. Well, does that stand a chance of being true? Well, let's see. If we do A dot A using this formula, we will get A1 squared plus A2 squared plus A3 squared. That is indeed the square of the length. So, check. That works. Okay? Now, what about two different vectors? Can we understand what this says and how it relates to that? So let's say that I have two different vectors, A and B. And I want to try to understand what's going on. So my claim is that we are going to be able to understand the relation between this and that in terms of the law of cosines. So the law of cosines is something that tells you about the length of the third side in a triangle like this in terms of these two sides and the angle here. Okay, so the law of cosines, which hopefully you have seen before, says that, so let me give a name to this side. Let's call this side C, and as a vector, C is A minus B. It's minus B plus A. So it's getting a bit cluttered here. So the law of cosines says that the length of the third side in this triangle is equal to length A squared plus length B squared. Well, if I stopped here, that would be Pythagoras, but I don't have a right angle. So I have a third term, which is twice length A, length B, cosine theta. Okay? Has everyone seen this formula sometime? Yeah, no. I hear some yes, I hear some no's. Well, it's a fact about, I mean, you probably haven't seen it with vectors, but it's a fact about the side lengths in a triangle. And, well, I'm not sure that well, let's say if you haven't seen it before, then this is going to be a proof of the law of cosines, if you believe this. Otherwise, it's the other way around. So let's try to see how this relates to what I'm saying about the dot product. So I've been saying that length C squared, that's the same thing as C dot C. Okay? That we have checked. Now, C dot C, well, C is A minus B. So it's A minus B, dot product A minus B.
Okay, I was just monitoring the live stream and I just figured out the encoding sometimes is getting overloaded and it is causing a bit of problem. So I was just figuring out, can I just change the encoding settings? Uh, I don't know how, but yeah, I was just figuring out. So let's just ask an AI to. I'm just for give me a minute. I'm just figuring out what should be the encoding setting for perfect encoding. What? Um, I don't know if you can see the OBS, but it's okay. I just have to figure out the bitrate for encoding. So okay, it's really complicated to live stream because I was just monitoring the stream and I just figured out the whenever I do okay. For YouTube upload sequence encoding alpha. Okay, let's calculate the bitrate here. So if I get the upload speed, I just need to figure out my upload speed. So okay, so maybe I chose the wrong day to stream because uh, today only I was just figuring out and monitoring that the internet is unstable at my place. So okay, never mind. Yeah, it's pretty low. It's pretty low. It shouldn't be like that, but yeah, it would be around 9.5, 9.83. Okay, okay, it's deployed on Versal. 9 point. Let's consider as no. I will consider it as 9 only. Okay. So minimum bitrate should be 5040. Recommended is this, maximum is this. 5040 should be the minimum. 5040. Okay, I applied the bitrate and it should be fine.
What do we want to do in a situation like that? Well, we want to expand this into a sum of 4 terms. Are we allowed to do that? Well,
so basically here we studied about the law of cosines and the geometrical representation of dot product, which is AB cos theta. That was it now. AB cos theta. Yeah, magnitude of A and B and AB cos theta. Okay, what's next? So if we have to figure out C, we can write it in the terms of A minus B vector. Okay, we are just viewing it from another dimension, so it's something like that only. Okay,
this term is, this is the only difference between these two formulas for the length of C. So if you believe in the law of cosines, then it tells you that yes, this is a proof that A dot B equals length A, length B, cosine theta. Or vice versa, if you've never seen the law of cosines, but you're willing to believe this, then this is the proof of the law of cosines. Okay, so the law of cosines or this interpretation are equivalent to each other. Okay, any questions? Yes?
Why isn't there cosine theta in the second one?
So in the second one, there isn't a cosine theta because I'm just expanding a dot product. Okay, so I'm just writing C equals A minus B, and then I'm expanding this algebraically, and then I get to an answer that has an A dot B. So then if I wanted to express that without a dot product, then I would have to introduce a cosine, and I would get the same as there. Okay? So yeah, if you want, the next step to recover the law of cosines would be to plug in this formula for A dot B, and then you would have a cosine. Okay.
Okay, I guess it was a clipped video of the overall video only for dot products. Yeah, so that was it for dot product. So basically we just have to the summary of this dot product is basically law of cosines, and when we do scalar multiplication of the when we do dot products, so what will be its value? So magnitude of a into b into cos theta. Okay, so let's head to the PDFs. Okay, let's see what's this. What does geometric definition means? Yeah, so this is the whole thing that we studied in this lecture. So how we can expand it? So this is how we can expand it. All right, and yeah, here C vector equals to A minus B. Okay, so they are going in the same direction, so we count it in a positive direction, and it is on the different directions, so we consider it as negative. And law of cosines, isn't it like a squared plus b squared plus 2ab, okay, minus 2ab? So it is like a minus b whole square of a minus b formula. Yeah, kinda. Okay, what more things do we have? Reading and examples. I will do that. I will do this too. I need this too. So okay, we will first read what's here. Okay, I just got a response from OBS that the encoding overloaded. I guess it's fixed now. Yeah, nah, it's not fixed so far. So encoding overloaded kind of things. Okay, fine. We have to manage that. There's no substitution. So yeah, let's study the dot product first. can't I just zoom it out? I can't. I have to zoom the whole thing. Okay, I really feel or I really felt that uh, I talked a lot. It drained a lot of my energy. So I will just try to speak less and study. Okay, so it described it in the dot product basically in the both of the form algebraic and geometric form. So in basically in algebraic form you can write it as this. Uh, if we go here, let me select pen. Okay, so in basically in algebraic form we can write it as like we have to find a dot product, then it's simple is a1 b1, it's 1 plus a2 into b2. Yeah, it's simple as that. We have to do nothing fancy, just the core concept. So if we can solve the questions 6.5 and 1.2, so we can also solve this mentally. So yeah, it comes out to be 16, but how it comes out to be 16, that's the main thing. So uh, 6 plus 1 7 and 5 plus 2 7, 5 plus 2 7. Wait a minute, so 7 7 it should be 14. What am I wrong? Huh? It's 6. Okay, it's 6 into I just added it. We have to multiply it. Okay, it's a silly mistake of mine. I have to make a notebook. um New page, let's write it as rename as silly mistakes. I can write the silly mistakes over here. So first one that I noticed is confused about, no, misplacing misplacing add and misplacing between addition and multiplication. Okay, it's the one thing. Can I save this? Command S. Okay. Next thing. So what's the next thing? Um. Okay. So let's view the geometrical view. So the figure below shows A and B, A and B. Okay. And yeah, this is A minus B. So yeah, this same thing. Uh, AB cos theta. So this is the whole derivation how A into B, A dot B comes to AB cos theta. This same thing uh, the instructor described us, showed us in the video lecture too. So yeah, this is a proof. This is a derivation of the whole thing. So from the algebraic definition of dot product, we easily get the following algebraic law: uh, A into B plus C, A into B plus C into C. Yeah, it's simple. It's the basic law. So final dot product of A and B. A is this, B is this, and cos theta is given. So we just have to put the AB cos theta. 4 plus 24. 4 plus 25, 20. Okay, I have to see how it. So it's 10 root 2 by 2. How it came out to be 10 root 2. So um okay, let me just see. Um if we take 25 29 and 29 is 29 is prime now. I think so 29 is prime. How it came out to be this number? I'm not sure. I have to ask the AI. Wait a minute, let me check one thing. Six, okay. Okay, so yeah, got it. I messed up again, but it's fine. I got to learn the whole thing. So it's like, okay, so let's say we close this. So here AB is, so here AB is 2.5, and so pi by 4 in cos, so this will be root 2 by 2, so 2 dot root 2 by 2, so the answer comes out to be 5 root 2. Okay, okay, it was fun. This is 1 into 3, so A is this, B is this. What we have to find? We have to find A dot B. A dot B. Okay, so isn't it simple? Like, yeah, it was a simple term. So let's see if my thought process is correct right now or not. I haven't seen much of the answer. So 1 into 3 plus 2 into 4. That's the whole thing now. So 8 plus 3, 11. Oof, finally, right. Okay, we can move on to the next one. So 3-dimension vectors. What's the question? Okay, so dot product works the same in 3D as in 2D. If A equals to this, B equals to this, then A dot B equals to this. And geometric view is identical, and same as proof shows A dot B equal to AB cos theta. So in 3D we have 3 axes. Okay, so what we're gonna do now, two legs of a triangle AC, A and C, okay, and AC is this, AB is this, and we have to figure out AC into AB, AC into AB, which is BC, then it comes out to be what? The geometric view of the dot product implies the angle between the legs is pi by 2, that is cos theta equals to 0. Okay, I have to skim through the trigonometric values first. After that I can solve this. Okay, so definition of the term orthogonal and test of orthogonality. When two vectors are perpendicular to each other, so these are perpendicular. Okay, these are perpendicular to each other. How we say they are orthogonal, as seen in the example, since cos pi by 2 equals to 0, the dot product is a test for orthogonality between vectors. Okay, so A is perpendicular to B, which means A into A dot B equals to 0. Okay, dot product and length. Both algebraic and geometric forms for dot product show is intimately connected to length. In fact, they show for a vector A. So yeah, magnitude of the whole thing. Okay, so magnitude squared magnitude of the whole thing. Okay, let's show this using both views. Algebraically, uh, this is this, and A dot B is okay. We just multiplied the same axes. It comes down to be this. Geometrically, the angle theta between A and itself is 0. Therefore, A square cos theta. Okay, as promised, both views give the formula. Yeah. So this session wasn't that much hard, but yeah, it just it's just based on two major formulas. So we do have problems it too, right? So how many problems are there? There were one, two, three problems. Let's see the problems. These are solutions. So we have problems. Okay, I believe the problems would be a bit tough. Okay, if it's equals to 0, then it would be pi by 2, right? It would be pi by 2, cos pi by 2. Am I right? Cos pi by 2. Yeah, I think so. Yeah, it's pi by 2. Okay, and we can compute this. So 2 plus 6, 8 plus minus 20 minus 12 is the angle between these two vectors acute, obtuse, or right angle. Uh, how do we find the angle? How do we find the angle? That's the question. How do we find the angle? Okay, this is right. Okay, let me see. How do we find the angle? I don't know that. Let theta be the angle between the vectors. Since dot product is negative, we have cos theta bigger than cos theta or lesser than 0, which means theta is bigger than pi by 2. The angle is obtuse. Okay, okay, got it. Yeah. So only one question remaining. Suppose this is B. Also, B makes an angle 30 with A and AB equal to 6. Find magnitude of A. Okay, what we can do. So, okay, let's just work on the thought process. I will calculate. For calculation, I need trigonometric knowledge. Uh, let's work on the thought process, which is important right now. Um, so what we have studied that A dot B equals to A B cos theta. What we have A dot B, which is 60, which is 6. A dot B, which is 6. Okay, find magnitude of A. We have this whole thing equals to 6. And we have this equals to 30 degree, and we have b, value of b, 2 to 1. What do I have to do with this 2 to 1? So if I get to figure out what we can do with this value, then we can figure out what will be a. Okay, it's getting interesting. Okay, I couldn't think of something so good, so I'll just give it a minute once again. But let's see. So how do we get this 3? The magnitude of b is 3. um 448. Ah, okay. We could have calculated the magnitude of b, because if, let's say, if we will solve it here. If b equals to um 2 comma 2 comma 1, then it will be, if we just square it and under root add it, so it will be 441. I mean, we just have to plus it, so so under root 9, which will be 3, so that will be magnitude of b. Okay, we could have done that. I missed that. And cos 30, I have to revise. Oh, Trigno, advanced Trigno, not even advanced. Okay, pi by 6. It comes up to pi by 6. Pi by 6, 6 and 3. So yeah, here we have uh, all the required terms. So 2, 4. Yeah, we can solve this like, uh, if we have 6 equals to magnitude of a into 3 dot, what's that, root 3, root 3 by 2, root 3 by 2, root 3 by 2. So uh this would be 2 to 4 equals to a root 3. So 4 by root 3 equals to a, if I'm right. Yeah, that's it. Okay, it was fun. It was fun. This question was fun. Okay, I am planning to study for. We completed 2 sessions in 2 hours around. So yeah, basically, uh, if we go onto this page, it will take us 8 hours to complete just one thing. So hopefully I can complete in 2 days. And then this thing, I don't know. Okay, I will just try to skim through this. Let's finish it quickly. Okay, let's see what's this. So basically, uh, this kind of thing is the whole summary of the lecture. So let's see. So this is just a description of cos theta, use of dot products, lengths, and angles. Okay, so this is just the expandation of the cos theta, how cos theta got expanded into different forms, how we can uh, use it in different forms. Okay, okay, it's not that complicated if we know it at the depth, or we can just navigate the path step by step. But if we see everything at once, then it seems a little tough. Okay, do we have a reading material? uh, we have some examples. I don't think this is the core part or the useful part, but yeah, let's study. So uses of dot product, find the angle between this and this. So algebraically we have this into this, so 2 -1 and then again 2 3. Okay, algebraically it's easy, geometrically it's kinda complex. So geometrically we have this thing, and this thing we expanded it uh, into this AB cos theta, and it comes out to be 2 3 4. So 4 6 under 6, and then 4 cross out, so under root 6. Okay, how it comes out to be 6? In this comes out to be root 6, but how it came out to be root 6? Uh, we have to see. We have to see it once. Okay, it's 211. It's 211. So it's 2 -1 +1. Uh, it's 4 1. Okay, okay, it's 4. The the square of negative will be a positive, so it's fine. Yeah, so it's under root 6. So double under root 6 into cos theta. So combine these two, we have 6 cos theta equals to 3. So cos theta will be 3 by 6, 1 by half. Okay, okay, so we got 3 from here. That the answer would be 3, and we got 6 under root 6 under root 6 equals to 6. So 6 cos theta, so cos theta will be 1 by 2. So 1 by 2 means pi by 3. Okay, so are these orthogonal? So orthogonal means that they both are perpendicular to each other. They both are perpendicular onto the same plane. That was the definition of what? For what value? Okay, so first these are orthogonal not. So vectors orthogonal if dot product is 0. Okay, so taking dot product, So if we take a dot product A into B, it's non-zero. For what value of A are the vectors A and okay, so if we have this and this vector, what we will put at A so that it will be a right angle. Okay, so if we make a equation by putting it to 0, then we can solve it and get the value. Okay, in the given figure, vectors b1 a and b1 are orthogonal as a and b2, as are a and b2 are orthogonal to. Okay, if all the vectors are the same length, what are the coordinates of b1 and b2? Okay, it's complicated. B1 is A rotated 90 degree clockwise. B1 is A which is clockwise and it's anti-clockwise. Okay, okay. Let's show that B1 equals to A2 minus A1. Okay, it's easier to check that A2 minus A1 equals to A, and A2 minus A1 dot A equals to 0. Okay, the figure shows that putting the negative sign on A1 means this is turned clockwise from A. Thus, uh, A2 comma negative of A1 equals to B1. So B2 is 90 towards anti-clockwise. Similarly, B2. So B2 will have negative of A2. Okay, yeah, it's understandable that how we can solve this. Okay, last one. Using the vectors and dot products show the diagonals of parallelogram have equal lengths if and only if it's a rectangle. Okay, we will have to make use of two properties of dot products. That okay. So this is orthogonal property and this is like the normal property that we tend to follow. So referring to the figure, we will also need to use fact the ABCD as a parallelogram. So AB equals to DC. Yeah. So we have AC equals to AB plus BC. So AC equals to AB plus BC. Yeah. And BD equals B and D equals to uh, B and D equals to BC plus CD. Okay, which is equal to BC uh, minus AB, BC minus AB. Uh, B and D. Yeah, yeah. Okay. So taking the dot products. So from here we have to substitute the values that we get here, and we can just do it. Okay, let's see how it goes. So this AC means this, and we substituted the values this into this, and we get AB square plus 2AB. It's the same formula, a square plus b square plus 2ab, 2a and b. Okay, yeah, it's the same formula. and yeah, here's same 2, but it's a minus b whole squares formula. Okay, so combining these two we get this. Then okay, these show diagonals have same length only if AB is perpendicular to BC. That is, if and only if the parallelogram are orthogonal to each other. And it was complicated. It was definitely complicated. But yeah, this session was not that tough. But last problem seemed complicated to me. I will just revise it in a go tomorrow or whenever I just study next. Let's see. Vector what's that? Vector components. Vector components. So component of f along t, so it's t, is what causes pendulum to swing, right? Yeah. Component of along n, component along n, to zoom in. So component along n is responsible for tension of the string. Yeah. Yeah. So what's in that? What do we have to do? Okay, let's see. Components and projection. If A is any vector and U is a U cap is a unit vector, then the component of A is direction of U cap. Component of A is direction of U cap. Okay. Now the component is scalar. If theta is the angle between A and U cap, and since U cap equals to 1, and so okay. So here we have to take the cos theta, and then we will take the cos theta on this on the side where uh, the angle lies, and this is sine theta. Yeah, this will be projection for cos and this will be projection for sine. Okay, the figure shows that geometrically this is the length of the leg of the right angle and hypotenuse A, and one leg parallel to uh, u cap. Okay, so this is doable at this point of time. We also call the leg parallel to u cap and orthogonal projection of A on u cap. A on u cap. Okay, okay. So u cap equal to B by magnitude of B. Is unit vector the same direction of u? Okay. You can find the component of A in the direction of B. So A equals to 2, B equals to 5, and theta equals to pi by 4. Okay, it was simple, but it took me some time to grasp the concept. 2, 3 plus 4j. 3 plus 4j. So it would be 3 plus 8, 11. Okay, I got how it will be 11, but how it will be 11 by 5. So unit vector direction of B. So okay, so we have to remember that unit vector is B by magnitude of everything. So if I try to solve this, it came out to be 3 plus 4, 3 plus 8, so yeah, 11. And so we have to find B by magnitude of B. So magnitude of B will be 16 plus 9, 25, 25, 25, 5. So yeah, 11 by 5. Yeah, I think we can move ahead and let's see, find a component of A in a direction of U cap. So we have everything present here. So we are doing A into U cap. So A is this 2 minus 2 into 0. And so it came out to be wait a minute, it came out to be minus 2 plus 0. So minus 2 from here and 0 from here. The negative component is okay. It says the projection of A and U cap is in the position direction, in the opposite directions. So A is going upwards, U is going to this direction, A is going to this direction. So yeah, it's on the opposite direction. So we just have to take this into account and use a negative sign. Yeah, I think. This was the example, and we have only this thing left. Like we have three questions here. Let's see how it goes. Okay, let's wait a minute. Okay, I can start solving the questions now. So let's A equals to this, B equals to this. Find a component of A interaction of B, and a component of B interaction of A. Okay, the same. It's the same thing that we have that we were doing here. Or I can just control A, delete. So component of A interaction of B, it's a simple interaction of B. For one thing we have to take A dot B by magnitude of B. It's little too thick now. I have to use the thinner one. Okay, for the second time I said lighter instead of thin. So what's A is just E and 10. Okay, yeah, so it comes out to be under root 25, so it's 5. So this mod equals to, so the value of this mod comes out to be 5 because of if we take this, it comes out to be under root 25. So yeah, it will be 5. And then at the upper section we have what we have. Three. So we have 3 plus 12, 15. 3 by 1 is 3. So yeah, I will just tell you how it came to be 15 quickly. So 1 into 3 it's 3, 4 into 3 it's 12. So that's how we solve the vector values, and it came out to be 15. So if we do the next thing, which is we can do b into a by in the direction of a, so it would be uh, what's b, again the this thing will be 15 only, 15 by under root a, so under root a will be 3, 9, 9, 10, so under root 10. Yeah, so how it got to be 10? If you are confused, then you can just see uh, 3 square of 3, it's 9, plus square of 1 is 1, so 9 plus 1 is it's 10, so it came out to be 10. Okay, fine. So we have figured out this, let a equals to this, b equals to this, find the component of a in the direction of b. If a equals to this, okay, we will just figure it out. If a equal to in direction of b, so we have to do this. So first a into b equals to 9 plus 20 plus 0, so 29 by 6, so 16 by 20, 29 by 5, so it should be 29 by 5 if I am not wrong. Yay, 29 by 5. Let's go. So finally I'm solving these questions correctly, I would say. Yep. Yeah, so next one, let a equals to this, b equals to this, for what values of a the component of a along b is equals to 0. So we have to find the orthogonal of what a is it negative. Yeah, so we can just calculate component of a along b, so we just have to calculate the magnitude of b, which is 3 plus 9 plus under root 10 by 6, yeah, under root 10 by 8.6. No, no, I said it inversely. It is inverse of that. So what is the question? So what value of a the component of a along equals to 0? Yeah, it will be 0 if this thing cancels out this, so it will be minus of 6, and just to be negative, so this should be bigger than a, so it should be, so a should be smaller than minus of 6. Okay, for what angle theta the component of a in the direction of b equal to 0. Yeah, so it should be equal to pi by 2. Yeah, it was fine, bro, come on. These weren't so hard questions, but these were fun questions. Yeah, so I believe um, we can solve more. I mean, like if I revise it again and again for 1 2 times, I can solve in a better way. Yeah. Yeah, so we solved the session 4, uh, area and determinants in 2D. This will be new thing, determinants. So yeah, uh, we will just I will just do it tomorrow. I want to revise it again, and tomorrow I will study in 2 sessions, I believe. I will just have to plan it accordingly. So yeah, hopefully uh, we will start with maths for CS2. I want to study maths for CS first, because before Python and everything, because uh, this math thing that we are doing, it will be a slow, it will be slow, and in a way that we can gain and grasp the concept. But maths for CS, it will be a fast paced thing where we will skim the mathematics once, because okay, let's open this. So we if we skim the mathematics once, then we can start with CS topics, which will be a huge boost to me. So that's what I'm planning to do. So we will start with proofs, structures, counting. So I am planning that I will finish till at least till counting tomorrow. At least till counting. So how many lectures or readings we have to do? Uh, so we have 11 readings. 11 readings in just first introductory proofs. Okay, it won't be that simple. So okay, it will be sets, recursive definitions. So mainly it will just build a thought process. Then GCDs, okay, it will take time to grasp. Euler's theorem, digraphs, it will take time to grasp. So I think I can finish two, maybe, till if I finish section 1. Let's see how long it is. I'll go with this. It will be short, of course. So I will do this. Can we have slides of the class too? Where are the slides? Okay, what's the length of lectures? I have to see that too. Okay, let's see. It's of 6 pages, and so it's mainly theory in a good way. So yeah, I will just read it. What's the length of lecture? There's no lecture. What are you talking about? There should be lecture. Okay, there must be lectures, but there isn't. So it was surprising for me. It is surprising for me. Okay, let's see. Yeah, there is lecture, which is of how many minutes?
In 6.
So which is of 9:30 minutes. So we have two parts of this lecture. So yeah, they are very quick lectures. Yeah, so part 1, part 2. Okay, at least in the first session I will do this only. uh, First session I will do this. I'll just note it down, make a, probably I will make a channel to-do list, like to-do list. Now where my to-do list went by? Here it is. It's at bottom. I want it at top, like at very top. Can I pin it at top? Yes. So maths for CS, at least 1 unit, at least 1 unit. I need to finish it tomorrow. Then revise vectors, and then finish what we were doing. Finish till part 8. Yeah, we did 4 sessions today. We can do 4 sessions tomorrow too. So 4 and more, not only 4. Finish vectors part A, which is of 4 more sessions. Yeah, so that's it. That's what I want to do. Okay. And also no, yeah, so that's it. Yeah, I thought that I should explore a little poker theory today, but I am a little exhausted today, so yeah, not today. Yeah, I'll come to study tomorrow morning, probably early on. So yeah, okay, I will keep this tab open, and can I close it? Probably, yeah. Okay, I will just end the stream now, and I will close it to what's running here. Okay, bitrate calculator and all, I will close it too. It's not needed. Alright, I will just close the stream at this point of time. And yeah, it was a very fun session. I learned, uh, vector in a very um, thought thought breaking way, because this was something new. And also I do have to learn a bit of Trigno, uh, which I will do beforehand before coming to stream. So I will just write it in Discord that yeah, I do need to learn Trigno too. And to list only, I will set it revise Trigono. Okay. Alright, I will just end the stream now. It was really fun.